Hello everyone. Welcome to Sweat Talks. I'm Joshnashree from Cybersecurity and my partner Madhuri Priya from Cybersecurity. This PPT was guided by Dr. M. Prasad Sir, Associate Professor, Department of CSC. Today we are here to explain about the topic efficiency and performance. Let's look into the topic.
Efficiency. Efficiency depends on disk allocation and directory algorithms. Type of data kept in files directory entry. Pre-allocation or as needed allocation of metadata structures. For example, Unix nodes are pre-allocated. Fixed size or varying size data structures.
The first topic in the performance is disk cake. Disk cake is a mechanism for improving the time it takes to read from or write to a hard disk. And the disk cake can also be a specified portion of random access memory for disk sectors. The disk cake holds data that has been recently read and in some cases adjacent data areas that are likely to be accessed next. Whereas the disk A consists of separate section of main memory for frequently used blocks. Our next topic is about free behind and read ahead techniques. The free behind and read ahead techniques is used to optimize the sequential access, whereas it is used to improve the performance of PC by dedicating section of memory as virtual disk or RAM disk, keeping data and metadata close together. Free behind and read ahead techniques is nothing but free the behinded block and read the forwarded block. Our next topic is buffer cake, whereas it consists of separate section of main memory for frequently used blocks. Synchronizes writes sometimes requested by apps or needed by OS. No buffering or caking writes must hit disk back acknowledgement. Asynchronous writes more common bufferable faster. Free behind and read behind techniques to optimize sequential access. Reads frequently slower than writes. In this slide, we can see there are two types of figures, whereas the first figure does not consist of unified buffered cake, and the second figure consists of unified buffer cake. So let us look into the first figure, whereas the memory mapped I/O consists of two buffers. One is a paste cake and the second one is a buffer cake. What is a paste cake? Paste cake is nothing but it stores the pages which are accessed frequently. Coming to the butter cake, it stores the frequently accessed blocks. So, how it works? First, if we take a data from the memory mapped I/O, it checks to the paste cake and then it is forwarded to the buffer cake. Whereas the buffer cake, it takes the data from the secondary devices. So, coming to the second picture, it does not consist of two cakes. It only consists of a single cake which is unified buffered cake, where it stores the both access disk box and the space so that the CPU can access quickly.
Backup and recovery. System failure, for example, sudden power outage, may result in loss of data, inconsistency of data. File system recovery techniques. Consistency checker compares data in directory structure with data blocks on disk and tries to fix inconsistencies. For example, FSCK in Unix, CHKDSK in Windows. Backup use system programs to regularly back update from disk to another storage device. For example, magnetic tape or other disk. Recover lost file or disk by restoring data from backup.